Okay, so we ended up with a couple of definitions of take and drop functions which operate on the front of a list by either taking the elements or discarding elements from the front of a list to build its answer list. Now we're going to look at some properties of these functions, and really this is an exercise in writing QuickCheck properties, but also in certain aspects of QuickCheck that are useful to know about. So I'm going to start by just looking at take in isolation. I mean, I think the interesting properties are the ones that relate these two together. And they, in some ways, form a nice specification of what this pair of functions does. But for now, I'll just focus on one of them. Let's just look at take. And we'll think about a property that we could expect of the take function. Well, if we're going to describe a property of the take function, we'll need enough arguments to our property in order to actually state what the property is. So let's assume we have some number n and some list x's. So one very simple property is that the answer we get by taking n elements from x's, what can we say about that? Well, maybe it shouldn't be bigger than n. Or rather, the length of this list shouldn't be bigger than n. Let's try that out. The length of that, the number of things we get, should not be bigger than n. It's less than or equal to n. Because we ask for 100 elements, and we have 100 elements, we'll get 100 elements. If we don't have as many as 100, we'll get less than 100. We shouldn't get more than 100, right? So let's try that property out. So I'll reload it. I've imported test.QuickCheck, so I should be able to run QuickCheck on prop take, and we'll see what we get. In fact, we see that the test fails. It fails because n might be negative, and when n is negative, the length of the list, which is never negative, will not be smaller than n. So there's a number of ways we can fix this, and I'll explore a couple of them here. The first one is to actually use another function from the QuickCheck library, and that is a kind of filter operation which allows you to filter out only the good tests. And here a good test is one where n is greater than or equal to 0. We're not interested in this property when n is negative. Well, the property doesn't hold when n is negative. So if this is the property we're interested in, it's a property of only when n is non-negative. So one way to express that is to use a QuickCheck library function, and this looks like an implication operation. It's a double equal arrow. You should think of this not as a logical operation, but rather as a QuickCheck filter. It instructs QuickCheck which tests from the random data that it generates, which things to keep. And we want to keep tests where n is greater than or equal to 0. So when n is greater than or equal to 0, this is the property that should hold. So it looks like a logical implication, but it's not. This only works in QuickCheck functions. And actually, it isn't just a logical operation. It actually changes the way that QuickCheck behaves. QuickCheck will now throw away tests which don't satisfy this guard, this Boolean expression. So we reload that. We can try and run that again. Oops, we're still failing. What did I do wrong? I didn't save the file. Okay. I really should get better at that. A few more years maybe. Okay, so we see that now QuickCheck passes the test as we hoped. Now, there are other ways that we could have fixed this. This is one way of doing it, which relies on a QuickCheck library operation. This is okay, but this is only really useful when the property, the guard, is relatively simple. And to explain what I mean there is that to think about what actually QuickCheck is doing here. So what QuickCheck is doing is randomly generating values for n and x's as our possible test cases. And then looking at this condition, and when this condition is true, it has a valid test and it goes on and does that test. When it's false, it throws that test case away and generates another one. Okay, so because it randomly generates numbers, about half of them are going to be negative. So basically, in order to do 100 tests, it probably has to generate about 200 cases. And that's not too bad. But now imagine we wanted a property, not this one, but some other property that basically only worked when this list is a sorted list. And whenever the list, and so we want to actually check that the list is sorted in some guard. That means every time we generate a random list, if it's not sorted in order, we throw it away. What will actually happen is, well, in this case, we'll only ever generate really small lists because the probability of generating large sorted lists is extremely small. So this is a strategy that easily breaks down. You'll easily find that QuickCheck will actually give up. It will basically say, well, I've tried 1,000 times, I couldn't find any good values, I've given up. So a more constructive way that doesn't use any QuickCheck magic at all is simply to make the property hold in some other way. So one way would be actually modify the test itself, the property itself. Well, what I'm going to do is get the same effect by modifying the value of n. So if I want a value of n which is never negative, I can do that using a function. I can look at the absolute value of n. So what I can do is I can define, I'm going to make a local definition, and here I'm going to use a let expression rather than a where clause. It's more or less the same thing, but this is something that we use. A where clause is part of a definition, a let is part of an expression. That's a minor difference here. Let's call n prime to be the absolute value of n. So now the property we want is a property for this n prime and not for the n we started with. So we take the absolute value of n to get a non-negative thing, and the property holds for all of those non-negative things. So that's an alternative way of fixing it that is more, in general, this will be a more efficient way of fixing things, and doesn't rely on QuickCheck library aspects. Okay, let's move on to relating take and drop. Also for n and x's. And the idea here is that we're going to relate these two. So one of them grabs things on the front of the list and the other one throws them away. And the intuitive idea is that if we take all the things we've taken and all the things we've discarded and join them back together again, we should get back to the list we started with. So let me have a go at that just quickly. Let's say we drop n things from x's and we join that onto what we get by taking n things from x's. We should get back to where we started. We should get back the list we started with. How does that look? Let's try that out. Let's run QuickCheck on that. So run that on prop take drop. And we pass the tests. But hang on a bit, is this really true? If we drop 5 things from the list 1 to 10, and we join that onto take 5 things from the list 1 to 10, this says we should get back what we started with. But we don't. So how could QuickCheck get this wrong? How could it say that it passed the test? Well, in order to see this, we maybe need to look a little bit more carefully into the type of prop take drop. I didn't declare it, but what is the type of this property? It takes a number, an int, and a list of things for which the things you can test for equality. For obvious reasons, we're using an equality test, so we better have a list of things where we can test the equality, and gives us a bool. Now, this is the problem. QuickCheck is trying to do random testing for something, but it's being given a polymorphic function. And so what values should it choose? What type should it choose for A here? Well, QuickCheck doesn't really know what type to choose for A, but GHC is just making a choice for QuickCheck by taking what it considers to be the simplest type. And what is the simplest type? Well, the simplest type is actually called unit. It's the void type. It's a type that only has one value in it, and that's the value. The type of that value is that value. So that's the type that is being used to test this function. We're randomly generating lists of voids. You can think of this, if you like, as the empty tuple. Can we really see that that's what's happening? Well, yes, we can. There is a function called verbose check. It allows us to see the test cases that QuickCheck is actually generating. So it has the same type as QuickCheck. We give it a property, and we verbose check it in order to print out the test cases. And here you see them. It's past 100 tests. This is the value of the number n, and this is the value of the list. Now the point is that because we've chosen this trivial type, this property actually holds, but it only holds for this type. Because when you take and drop, if all of the elements in the list are the same, it doesn't matter how you join them together, you'll get back where you started. So what we need to do, or the easiest fix for this, or the most straightforward fix, maybe not the easiest in terms of the number of characters we type, but that is to put the type in. But to put the type in and choose the type of the list that we want. So instead of letting it be polymorphic, which was our problem, let's choose. Let's say we're going to test this on lists of something. What kind of something should we choose? Well, we can choose anything we like. We can use lists of characters, for example, strings. And we can run it on strings, or we could choose, well, let's just take int, because that'll probably print out in a reasonably nice way. So now, if we reload that file and test it again, what we see is that we get a counterexample. You see that the examples that it used were all very small because it didn't actually have to work very hard. It didn't have to test for very long before finding a counterexample. It says when you drop one element from this list and then join it with take, we don't get back what we started. That's because we'll end up with 1 followed by 0 rather than 0 followed by 1. But if, on the other hand, we take and then drop, we reload that file and we do a verbose check. When you see then the test cases get much bigger. Actually, that's a general observation. When we do testing, QuickCheck will always start with very small tests and actually then ramp up as time goes by. So it always tries to find simple counterexamples. Okay, so the moral of the story is that we need to choose our types rather than let Haskell, let GHC pick one, because GHC might pick one which is too simple for the property we want. Let's fix this in our other example. What's the type we might want here? Well, I guess we could say it looks like we could use a similar type for prop take. Right, because the first thing is an int and the second thing is a list of things, so we could choose a list of int if we wanted. We could choose the simplest type we could choose actually is a bool. That would be enough to for this take drop example. So let's just save that one over there and reload it. Let's look at our property of take. Yeah, okay, that's all fine. Actually, what I wanted to show you was if we use the other solution, the one where we don't use this let, but we use this guy instead. Okay, I'm now combining the two. That's not the important thing. The important thing is now that I'm actually using this operator, if I now retry this test, I actually get a type error. And the reason is because as soon as we start using these special QuickCheck operations, we're actually moving from the world of simple Boolean values to something which is like Booleans but has extra features. These are the kind of QuickCheck features, and in particular this is control of the way QuickCheck behaves. So actually what happens is once we use this guy, we're actually changing from the type bool to a QuickCheck type from the QuickCheck library called property. This only exists in QuickCheck. And we're not going to use it for anything else other than QuickCheck. So there is a little pitfall here. If we want to use QuickCheck operations, these things become something more general, if you like. You can think of it as a bit more general than a bool. I think of it as a bool with benefits, or a QuickCheck bool, and that's a property. So that's something to look out for when we, so now it compiles. Whenever we use one of these things, we have to make sure that we switch from bool to property. There are a bunch of other operations for controlling what QuickCheck does, for example, controlling what it prints out and so on. I'm not going to go into the details of those because they're not so super central to the course. But there are lots there, and there are even other ways of fixing this property by using a special kind of pattern matching on the left-hand side. Again, these are all fancy features of QuickCheck, which are not really the central feature of the course. What I've shown you here and now will be good enough to get you started with the QuickCheck properties that you need.